Welcome to Electrical Grind. In the previous lecture, we saw how K-map is implemented and how it can be used to obtain the minimized functions. In this lecture, we will see the drawback that K-map had and how it could be overcome with this new method. So as previously discussed, the number of variables, once it increases, so does the number of squares in the K-map. So that results in failure of reasonable selection of the adjacent squares, as we could see during the 5 variable K-map. We had two maps overlaying each other, and that resulted in quite a difficulty during the selection of the adjacent squares. But as the number of variables increases, so for 6 variable we would have another 2 stackings. So this would overly complicate the square selection process. So for this we will be using the tabulation method or the Quine McCluskey method. So basically it is a the K-map was a trial and error procedural method, but this tabulation method overcomes this difficulty by a specific step-by-step procedure which ultimately produces a simplified standard form of expression for the functions, and it can also be applied to problems with numerous variables, that is more than 5, more than 6 as well, because it is also suitable for machine computations. But the only drawback of this method is that it is quite tedious for human use and also very prone to mistakes. So let us begin the QM method. So in this method we will firstly identify all the prime implicants, and then we will minimize them in the subsequent sections. So let us understand how the process of prime implicant determination is done. So for this we will first compare each minterm with the other available minterms. This is known as the matching process, and during the matching processes we will rewrite all the matched minterms in the subsequent sections, but only those which are differing in only one variable. So let's say there is one minterm which has this value, this literal, and the other minterm which has this minterm. So as we can clearly see, these two variables in these two literals are same, and these two literals are varying only in C and C complement. So by matching process we will eliminate these two variables and we will ultimately obtain the reduced minterm. So this process is again matching process again repeated for the new minterms found in the previous section, and then it will further eliminate all the common literals, and thus the remaining terms and the unmatched terms will comprise of the remaining prime implicants. Okay, so let us see the example. So in this example we have been given this function. So what we will do, firstly we will write the variables. Say here I have used w, x, y and z. We can also use a, b, c, d as the variables. So on the column side we will write w, x, y, z columns, and on the first row side we will use the decimal equivalent of the given minterms. So as we have been given the minterms 0, 1, 2, 8, 10, 11, 14 and 15, we will consecutively write it down, and then just as we do the BCD coding, that is binary coded decimal, we will encode all the variables with the equivalent binary representation. Okay, so after that, the first thing that we'll have to do in this process is group the binary representations of the mean terms according to the number of ones obtained in the column A. So let us see how many groups we can form. So in this, the first group, there is no one, so this will be our group 1. In these two in these three decimal equivalents of 1, 2 and 8, we can see there is 1 in each different positions, so this will be our second group. Similarly, since there is 2 ones, this will be our third group. There are 3 ones, so this will be our fourth group, and there are 4 ones, and this will be our fifth group. Now we will compare each term of these groups with the other terms of the groups, as we have previously seen that this will be our matching process. So let us see the next procedure. So any two mean terms that differ from each other by only one variable are now combined, while the unmatched variables are removed in the column B. So as we can see that we will first pair 0 with 1, then with 2, and then with 8. So the pairing results in 0, 1, that will give us this result. So as we can see that the three variables w, x, y are same for both 0 and 1. So they differ only by 1 bit in the z variable. So for 0, it is the z's value is 0, and for decimal value 1, the z's value is 1. So since there is a difference in 1 bit, we will represent it with a dash. Okay, similarly we will do it for 0 and 2 and 0 and 8. So wherever there is a change in the bit, we will replace it with a dash and let the other terms be 0. Now as we can see, like we have seen in the process, only that we will consider only those mean terms that differ by one variable. So here we have obtained 3 same variables and differing by only one variable. So this will be our result from the first two group comparisons. Similarly, we will now compare the other groups. So comparing second group with the third group, we can see for 1 and 10 there are two positions where we are getting different values. Sorry, 3 positions where we are getting different values. So we could have considered it, but as per the rule, we are required to find only one variable difference. So 1 and 10 will not be considered. So hence you can see we will not consider in section B 1 and 10. Now we will see for the other terms. So we'll check 2 and 10, and there we can see the first variable is differing, the second is same, third is same, 1, 1, and fourth is same. So yes, we can now consider the combination 2 and 10. So after matching 2 and 10, we will put a dash wherever the variable change is occurring at one position and let the remaining positions be same. Similarly, comparing 8 and 10, we can see there is a difference in this position and it will be replaced by dash. So next we will compare groups 3 and 4 and similarly groups 4 and 5. After careful consideration and matching processes, we have thus obtained finally these positions. Okay, so here now we will see whichever term has no other matching term possible, that we will consider as the prime implicant. So in this case, as we can see, 0 and 1 has only one varying position change and it does not match with the other groups. say for example 0, 1, 2 and 10, if we consider, there is a variable change in this process, this process and this process, so we will not consider. But we can look in these subsequent sections, not using the variable change as previously done, we can just match the dash terms. Okay, so this dash position and this dash position is not matching. Similarly for 8 and 10, 0, 1, 8 and 10, the dash positions are not matched. Again, if we see for 0, 2 and 2, 10, we will see the dash positions are unmatched. But in case of 0, 2, 8 and 10, the dash positions are matching. So where do we have dash positions? Here and here. Okay, so now we will see if there are if there are more than one variable that are differing, and if there is, then we will not consider it. So we will see the first variable w position for 0, 2 and 8 and 10, it is differing by 1 bit, so yes, it is okay. The second position is same, fine. Third position we have both the dashes, it is fine, and third position we have zeros and zeros, that is same. So as you can see, we can now consider 0, 2, 8 and 10. Why? Because they are only varying at a single position, that is a single variable. So we will write this combination in section C, where we will consider 0 to 8 and 10. So we will like previously done from section A to B, we will put a dash wherever there are differing values, and then subsequently write the other order. So there was already a previously dash from section A and rest of the variables as it is. Similarly, we can see that 0, 8 is matching with 2, 10 because their dash positions are same, and we will also consider it. While comparing the second group with third group, we can see that the dash positions are not at the same level, hence we cannot compare these two groups. So these two groups will not be comparable, so we will move ahead with the last group. So if we see that 10, 11, 11, 15, are they matching? No, they are not matching. So we will move to 10, 11, 14 and 15. Yes, the dash positions are matching. Now we will see if there are more than one variables differing or only one variable differing. So the first variable w is 1 for both the cases. In the second case, for x, we are seeing that they are varying by 1, and in the second the third variable y, they are same of value 1, and finally we have the dash at both z positions. So yes, we can consider this combination and we will obtain our next combination, that is 10, 11, 14, 15, and we will have 1 dash 1 dash. Okay, similarly for the last group we will check 10, 14, 11, 15, and we will obtain our last literal. Now as you can see, there are tick marks against all these, and there are no tick marks against this 4 and this one. Why? This is because the tick marks we are assigning for our ease of understanding that these are comparables. So not only comparables, but they are matching. So if there is a match possibility, we will put a tick mark against that decimal equivalent literal. Okay, so as we can see, there are two groups now, and both the groups formed have repeated cases. So we will see if there is a larger possibility of combinations. As we have seen, the possibility of combinations in 4 variables is 2, 4, 8 and 16. And the 16, all the 16 variables are combined, it yields a 0 literal, and if 8 are combined, it gives a 1 literal. If 4 are combined, it gives a 2 literal, and if 2 are combined it gives us 3 literals. So here we will see if there is a possibility of 8 literals combining, and as we can see, for 0 to 8 and 10 and 10, 11, 14 and 15, the dashed positions are not at the same level, so further grouping is not possible and we will stop our matching processes. Now so now we will see if there are same combinations, then what we need to do. So if a term appears twice in the table, then n is also a prime implicant. So we'll have to check here if it is a prime implicant. Yes, there are no matching possibilities, so these are the final prime implicants. So these are the prime implicants. So yes, it is also a prime implicant. Then it is treated as only one term, so we can take either of the two as one term, sorry, and we will finally obtain our desired minimized function in the SOP form. Here it is SOP form because we are considering min terms. If we would have considered max terms, it would have been the POS form. So let us see what is the obtained result. So the first prime implicant is at 0 1 combination. So the variables are w is 0, x is 0 and y is 0. So since 0 results in the complemented form, so the end product of this literal will be, so the end product of these variables will be the literal w bar, x bar and y bar. So this will be our first term. So and from this we just need to consider any one. So we'll consider this, you can consider this as well, it will give the same result. So we have dash at w. Now remember, wherever there is dash, we will not consider that variable itself, so this variable will be eliminated, and wherever there is a value we will only consider those variables, and combining those variables will give us the desired literal. So this will result in the literal x bar, z bar, and this will result in w and x, and finally we will add all the prime implicants to obtain the desired minimized SOP form. Okay, so the biggest advantage of this method is it gives us the true minimized form, where we could see that in K-map there were multiple possibilities, but here all the multiple possibilities are eliminated by the matching process. So this matching process helps us eliminate all the other possibilities, and therefore it helps us achieve the truest minimized SOP form. So with this, let us conclude our lecture on the chapter of Boolean algebraic minimization techniques. So what we have learned here is how simplification of functions with many inputs can be obtained over a single output. So here there are numerous combinations of inputs and we obtained a single output. Okay, and now in the subsequent lectures we will learn more about the circuits that contain more than one output, which are combinational circuits and sequential circuits. Also, I will be uploading one video covering all the basics, like what is variable, what is literal, and how we use logic 0 and logic 1 in representation of the variables in complemented or uncomplemented form. Okay, so thank you everyone.